Hello, hello. We will hang out for a minute and let folks show up. But I'm super psyched to talk about Python for AI. I will admit, I just spent a solid minute and a half trying to figure out how to take down a banner that was covering up my face. So that's no good. But it's all good because we're going to have a good time. It is Will from Major League Hacking in my new home. Yeah, this is me. Last time I streamed, I was in the Google office because I didn't have Wi-Fi, and I still don't have Wi-Fi, but my neighbor does, and she's very nice, and so she gave me her password. Yeah, prison is not the right name. Hi, Craig. Hi, Adam. Hi. The problem is usernames are hard to pronounce, but hello, everyone. Welcome, welcome. Let me know in the chat where you're calling in from and how the weather is where you are. I'm in Seattle, and it is actually incredibly nice and sunny. Also, actually, this is something that I'm curious about. It's raining for Adam. Something I'm curious about is what level of experience you have with Python. You really don't need much experience for this workshop, but if you have some, that could be nice. So, give me a 0 to 10 scale. How much experience do you have with Python? If you've done the other Python workshops, which you don't have to for this, it's not a requirement. But if you have, then that probably puts you at least a 3. Hello, hello. I'll say, and here's what I'll say. So I've been using Python for 6 years now. No, that's not. More like 5. And I work kind of professionally with it at Google. And I would probably give myself maybe a 6. That's what I'm giving myself. Obviously, rating scales are arbitrary, but it's kind of fun to get a sense. And I am going to stall because I haven't put my picture in these slides yet. Yeah, rating scales are hard. It's I don't know, are you are you an 8? Are you a 2? It's yeah. I used to do smaller scales where it's give me a 0, 1, or 2, and that sometimes is a little more helpful. It's okay, I'm easily on a 0 to 2 scale. I'm usually a 2. Am I a certified local Hack Day Learn 2022 Blahaj gang member yet? I'm actually not. Now I need to get on that before local Hack Day is done. I want to get my credentials. I don't know if I mentioned this, but just a few days ago I went to IKEA and I wanted to buy one of the sharks, the Blahajes, and they were out of stock. And it just crushed my little gay heart. I was very sad. But I did what I could. Oh, here's actually a question I have for y'all. One, how am I sounding? Is my audio okay? And then 2, actually, can you hear the aquarium over there? Because it's got a little bubbler so the fish can breathe. But the fish could probably do without breathing for an hour if I wanted to turn it off. So if you can hear it, let me know. I'm not trying to mess with my fish or anything, but they are actually fine. Oh, it's perfect. Incredible. I sound very Will-esque. Well, I'll take it. I mean, that is what I sound like. So, but yeah, I am super psyched to have you all here. We're gonna have a good time. Okay. I really have to get better about having all of my photos of myself in one place. Because I use iPhotos and I use Google Photos, but those are both disaster zones, right? Because there's just a constant stream of mostly memes, not even mostly photos of me. Oh, we got a question about the kombucha. I actually have it, so I brought it to the new house, and it's in the pantry. It's downstairs. I'm from a stationary camera right now, so maybe another time I can show off the kombucha. But for the time being, you don't have to trust me. The kombucha is doing well. Also, if anybody wants a SCOBY starter, I don't know if anybody's familiar with kombucha making, but you need a little starter. If anybody's in Seattle and wants some starter, I would be more than happy to gift you some. All right, it is 5 after the hour, so we can probably get going. Let's see. What is the best program? Use Python. I might not totally understand that question. If the question is what's the best use of Python, I could definitely answer that question and would love to. Let me know if that's actually like what you're getting at, because don't want to ask a question that you're not actually asking. I was running around trying to find my kalimba a few minutes ago, and I just found it. I recently moved, and so everything's in boxes, and I thought I was maybe gonna miss it. Also, to make good on my clickbait, I have this goose. This is totally unrelated from the workshop, but I know I said something about a treasure map goose. This is my treasure map goose. It's just this, I don't even know what metal it is, but it's a little goose that holds a treasure map in its mouth. You don't get to see the treasure map because that's my treasure map, but you do get to see the treasure map goose. Oh, there we go. Isn't that cute? Anyway, treasure map goose is going to watch over me as I do this live stream. I guess without further ado, let's just jump into it. Actually, we are going to have some further ado. I'm going to stall for 2 more seconds, because it is slow. Google Slides. I work at Google, and so I shouldn't be talking about slides, but it's kind of slow. Slides is really about to crash my computer today. You know what I gotta do is before I do the presentation, before I actually share slides, I should just save them all as PDFs. I don't know, does anybody have any pro tips for making Google Slides be less slow? Because I'm at this moment actually kind of concerned about getting through this live stream with Google Slides just not blowing up on me. And of course, I know I should have the answer here. But I'm looking for the answer. Okay, I think we can get going. I think has everybody polled on or not polled, but dropped their comment on how good they are at Python. You could also describe how good you are at Python with other words if you wanted to. Okay, I think Slides is going to behave, at least for a minute. So, now it's spinning again. Oh dearie me. I probably have to get a new laptop soon. I don't want to, because Bertrand is my friend. That's my laptop's name. Okay. Let's go for it. And you can just see Google Slides just trying its best. Oh, come on. Come on, Google. You can do it. I haven't even introduced myself because we haven't even gotten to the introduction slide. Okay, here we go. Welcome to Intro to Python. And I will click and wait 12 years for slides to go to the next slide. Okay, here we are. Welcome. My name is Will. I am a coach at Major League Hacking. I am also a software engineer at Google. I am here to lead this session and help everybody learn something. Hopefully, we'll have a lot of fun. And one fun fact about me is that my favorite programming language is Python. So we are going to learn all about AI and game development today. And kind of our rough overview is obviously a welcome, which is what I'm doing here now. We're going to do an introduction to game programming at a high level. We're going to get into building rock, paper, scissors as a video game, kind of heavy air quotes. We're going to build an AI-based opponent, and then we'll do kind of a review and a wrap-up. Now, if you are not familiar with Major League Hacking, we are the global hacker community. It is our mission to empower hackers, which we get to do for lots of hackers. You can see the big numbers. And we hope you learned something awesome today. If you are coming here to this workshop as part of Local Hack Day, that's awesome. Happy Local Hack Day. I'm thrilled that you are here. Oh, yeah, and Adam, per usual, just dropping. I actually had the check-in link ready, but I appreciate Adam keeping me sane and dropping that check-in link there. Yes, this is a local host workshop, and we are plopping it right into Local Hack Day. So get used to it. No, I'm not blonde. I'm still not blonde anymore. Okay, so we kind of did a high level, but what are we learning today here? We're going to learn roughly how a game works in general. We're going to learn how some game AIs work. We're specifically going to dive into kind of like the range of intelligence that artificial intelligence can have, from the very dumb to the more intelligent. And then we're going to put all that together to make a rock, paper, scissors opponent for our rock, paper, scissors game. So consider yourself welcomed, and we are going to dive right into game programming. So hit me up in the chat now. What is your favorite game, and what makes that game fun for you? I'm like interested in reading people's comments. I'll actually start. I'll go first. I have lots of favorite games. I'm actually, for Halloween, I'm flying to Boston specifically to play my favorite board game with some friends. It's called Food Chain Magnate. There are a couple of things that I love about this game. I think it has beautiful art. I think it has a lot of really complex strategy that kind of puts you in interesting positions with the other players. It kind of, forces you to make these trade-offs. And one of the things I love about it is it actually has very, very little randomness. I know some people like randomness in their games. Some people love, like dice rolling games. But for me, I like as little randomness as possible. And on the box for this game, Food Chain Magnate, it actually says 100% dice free. So that's something that I love about Food Chain Magnate. It's a really cool board game. I'd recommend you take a look at it. But I will wait for a second to see if anybody wants to share what their favorite game is and what makes those games fun. I threw out a couple ideas. It's it's having cool art. It's putting you in these interesting positions with other players. Although I think lots of people have lots of other things that draw them to games. One thing I'll say is that I am actually not a huge video game player. I'll play like Mario Kart. I used to be really into Borderlands, but on the whole, I don't play video games a ton. We were talking about any kind of game. Yeah, so Call of Duty is a perfect answer. I'm curious, actually, like for you, what makes Call of Duty a good game? That's something I'd be interested in hearing about. Cheer 100, not familiar, but interested. BGMI and Valorant, nice. Well, believe it or not, rules make games fun. This is at least this is the premise that I'm going to be fighting for in this workshop. Without the rules of a game, you don't know what you're doing. And I think, in fact, I'd go even further to say it's not that without rules games aren't fun. It's that without rules games don't exist, right? Games fundamentally are the rules that make them up. Even if you're playing a video game or a complicated board game, when it comes down to it, it's a bunch of specific rules that you're playing with. And I mean this seriously. So we threw out a couple of games. I'm actually curious, like Call of Duty, Valorant. Blahaj is not, unless the Blahaj community has come up with a board game, which would be awesome. I don't think Blahaj is a game, but I could be wrong. But I'm curious, to come up with specific rules that you can call out in these games. Blahaj Monopoly, I would play it. Even though I don't like Monopoly as a game, I would play Blahaj Monopoly. So one rule that I would guess, I know Valorant, Call of Duty, I think these are kind of first-person shooters. The rules about what happens when you die. I know in some games, if you die in that game, you kind of get respawned, or maybe there's a delay before you get respawned. Or in some games, you die and you just stop playing the game until you play another version of that game. So I'm curious for folks if there are any rules that they're like, oh, this is a rule that I think makes this game fun. I'll call out to one of those, that board game that I shared, Food Chain Magnate. One rule that I love is there are a bunch of milestones that people can get. And there's this mechanism that on a turn, if one person earns a milestone, so you're making food in this game, so there's a like the first person to make pizza, right? So say I start the round, and I make pizza on my turn, and that means I'm getting that milestone. But if anybody else can get that milestone on this turn, they can get it too. So I get the milestone, and suddenly that sets a clock going for everybody else to try to get the milestone. And so it puts everybody in this position where you have to really kind of think about what other people are going to do. And if they're going to make pizza, then I'm going to make pizza so I can get that milestone as well. This is an example of one rule in that game that I really like. But I'm curious if folks have any other rules from these games they play, from Call of Duty, Valorant, Cheer 100, Blahaj Monopoly, that they actually think are like cool rules. But we've talked about some complicated games, and we're going to actually hone in on some very simple games. We're going to talk about Tic-Tac-Toe. So in Tic-Tac-Toe, you start your turn, and you could do anything, right? Like that's kind of the setup. You could put an X in any box, any of those 9 boxes, or an O. Or you could put an emoji there, or you could turn the board into a birthday cake. No, that's not actually right. That's not how Tic-Tac-Toe works, right? Rules tell us what we can and can't do in a game. So in Tic-Tac-Toe, one rule is that you can only put X's and O's in unoccupied boxes, right? If there's already something there, you can't put anything there. And the only thing you're allowed to put into a box is either an X or an O. And your friend, if you were to play Tic-Tac-Toe and you tried turning the board into a birthday cake, they would tell you to stop. Or if you erased their O and put an X on top of it, they would probably also be upset. I think the same goes for trying to write emojis in board games. This is, okay, actually, tangent. I'm not sure if anybody is familiar with the band Coldplay or the artist Jacob Collier, but apparently they did a song together. I haven't even heard the song, but I've heard the name of the song is just the heart emoji. And it like really upsets me because it's like, how are we supposed to refer to this song like when we're talking? Are you really going to say like, oh yeah, the hit song heart emoji from Jacob Collier and Coldplay? And I'm like, I don't know, miss me with that. You know, just we have words, use the words. I think emojis are great, but I think for titles of things, I think emojis are hard. That's a little rant on putting emojis where they don't belong, like in a tic-tac-toe board. So this is ultimately why rules matter, because the other people playing the game with you expect you to follow them. And you and your opponent have to decide when the game is over as well and declare a winner. That is also a rule. So the good news is that computers are actually really good at rules, right? If you want to program a computer to play a game, in terms of rules, they can get it down flat. Computers do the same things as you and your friends, but unlike your friend, they will force you to play by the rules. There's no getting around the rules when a computer is playing. Okay, we're going to talk about state. Not Washington State, which is where I live, but state when it comes to a game. So state is what's happening right now in our game. For example, the locations of all of our X's and O's on our board. That would be our state if we're playing tic-tac-toe. And state is also what makes video games work. The game looks at the current game state, and it will go and look at all of its rules based on that state to figure out what happens next. For example, if our state says there's an O in the middle of the board, that would mean that the rule that says you can't place things on top of other things in tic-tac-toe, it's that rule plus the state that tells you that you can't put an X in the middle of the board on your next turn. So we need both state and our rules. The same rules apply each turn, but they depend on the state. The computer will look at that state, and it'll decide what you're actually allowed to do. And this itself is kind of a rule. Okay, so we talked about state. Do we have any questions about state? It's a little bit of a fuzzy concept until you actually start playing with it, which we will do in a second. But if we have any questions about state, we can talk about it. Cool. I see no questions about state. So then we're going to talk about a concept called the game loop. And this is actually one of the things that is really different in game development compared to a lot of other kinds of programming. In some ways, it actually is not that different from front-end JavaScript development. There's something called an event loop, but in some ways it's distinct. So the process of applying these rules kind of one after the other each time. This is called the game loop. And the game loop at every step looks at the state to determine what can be done next. So in our tic-tac-toe example, a computer would see the board and it would say, you can put an X in any one of the spaces, right? Because the rule is you can put X's and O's in any unoccupied space, and all the spaces are unoccupied. And if you're the player that is X's, then you can put an X anywhere. Now, once you've done that, it would play its move again using its knowledge of the rules, and it would say, I could put an O here to try and win. Right there in the upper left-hand corner. And this process repeats itself over and over again until we get to a place where, based on the rules, someone has won. Or, of course, with tic-tac-toe, you can have a draw. The computer will tell you when this happens. So that's enough tic-tac-toe. We're going to build a different game using some actual code. So we're going to dive into rock, paper, scissors. I will exit out here and drop this link. We're going to be using glitch, if anybody is familiar. Actually, I won't even try to get it from the slides because I have the link over here. Okay, here we go. And I will jump there too. In fact, for the time being, I will double screen. So we're going to come down here and click the Remix Your Own button. This will give you a copy of your very own that you can play with. So we have some basic starter code that we'll look at in a second. It'll probably load for a second. Awesome. Now, you may actually be required to make a glitch account if you've never used glitch before. This is super easy and it's totally free. So just take a second to do that. And now we have our own copy. Once you see this screen, you are good to go. Now, a note about this. Because this is your own copy, that means that this code totally belongs to you. You can edit it. You can break it if you want. You can reuse it in a different project. And most importantly, you can play around with it in a way that makes it your own. Obviously, we're going to actually get into the actual coding of this, and coding can be really hard. If you have not done a lot of large projects before, it is a process of learning how to overcome little issues. And making mistakes is totally okay. Everybody makes mistakes. In fact, making mistakes is... This sounds like... I'm about to say something that sounds like, oh, that's like some inspirational speaker BS, but it is like really true that like messing around and making it do something that it's not supposed to do is like, I think, actually the best way to learn how to program. So do not be afraid to mess it up. Okay, so now we are going to actually dive into using this code. In fact, I'll make this full screen over here. So we have basically one file that you can click on over here. Oh, this is really small, isn't it? Let me know if you want me to make this bigger so you can actually see. Actually, I'm going to make it bigger regardless. Okay, let me know if this is big enough. So what we're going to do first is actually come down here and click on Tools, and we're going to click Terminal. Now, the terminal just gives us a way of directly running our program up here. What to do? Read the slide. There you go. Awesome. So now, in order to run our program that is written in Python, we're literally just going to type Python3 and then the name of our program, game.py. And then if you hit return, it launches our game for us. Okay. We're waiting. Oh, Incredible. So you can actually play this game right here after you type out Python 3 and then a space and then game.py. I mean, you don't have to right now, but you can say, okay, rock. And we see, oh, we lost. And you could say paper. Say, oh no, we lost. You can say rock again. I say, oh, we drew. And if you do this enough times, the game will end. But you can also quit out of it by pressing Control-C. But this is Python code. What you're seeing right here is Python. Now, what is Python? Okay, we have some fun slides that I'll put back up because they're silly. What is a python? A python is a type of non-venomous snake. They're often found in Africa, Asia, and Australia. No, wait, that's not what we're talking about. We're not talking about a python. We're talking about Python, the programming language. It is what we call a general purpose programming language, which is one of the things that I think is so cool about Python is it can do almost anything. There are a lot of languages that really do one thing really well. So for example, historically we think of JavaScript as being a browser language for websites. We often think of C as being a systems programming language. We think of SQL as interacting with databases. We think of like MATLAB as being for kind of scientific computing. But Python really has a finger in all of these pies and can really do it all, from web development to data science to creating artificial intelligence, which is nominally what we're going to be looking at today. Okay, so remember the game loop. We're actually going to go and find our game loop in this code. So we actually brought it up and we were playing it, and we can actually see the game loop. So if we scroll down a little bit, and right here on line 84, if you have not messed with it at all, it's line 84, we see while not winner. And this basically says, as long as we don't currently have a winner, we're going to keep playing. And it basically will keep running until that winner is chosen. Now, the one key thing about Python here is the idea that we create separate code blocks by indenting. That's just creating that space at the front there. So you can see this is something that's unique to Python that a lot of other languages don't use. But so we say while not winner, and we're actually saying run all of this code, and then when you get to the bottom, come back to the top and check to see if there's not a winner yet again. And if there isn't, then run all of this code again and then come back to the top. So because all of this code has this indentation, this means it's part of this while loop, is what we call it. So you might be asking yourself, okay, we say while not winner, but how does it stop? And the answer is that it stops when that conditional stops being true, right? So if there's a winner, then winner is true. And not winner basically means this is true whenever there is not a winner. So as long as there is not a winner, we'll keep running. That was a lot to take in, so we're going to give ourselves a rest for a second. But we're going to kind of recap. We are programming a game using Python, which is a language. Our whole game runs inside this loop until the conditional of there not being a winner is no longer equal to true. Our conditional is whether the game doesn't have a winner, and so as soon as there is a winner, we will finish. So that raises the question, how do we actually decide if there is a winner? Where does that happen? And we can find that just a little bit further down in the code. Of course, the short answer is we're going to use our rules to determine if there is a winner. So one of the rules of rock, paper, scissors is that each player is going to choose either rock, paper, or scissors for their move. And our code will tell us how to follow those rules. Hopping back to check on comments. Looks like everybody's doing well. Nobody has any questions. If you have questions, drop them in the comments, and I will read them, and I will answer them. But if not, we will continue to charge right on ahead. So right at the beginning here, we have these statements where we ask move for the player move, and we make move for the computer move. Then remember our state, we update our state by adding that player move to our state list. And then we check to see who won the round. So we have this check winner function. It will take both our move and the computer move. Now, this is what we call a function. Ask move, make move, and check winner are all functions, which are fundamentally just blocks of code that do something specific. And the way that we can find out exactly what these blocks of code do is by finding where we have defined the function. So, for example, ask move, if we scroll up, we can see our ask move function is right here. And we can see the rules that kind of make up that function. Now, we're going to zoom out a little bit more, and we're going to talk about variables. So there are different types of variables that store different types of data. Two big types that we'll talk about are strings and integers. So a string, another word for a string is just text. So we might use the word text, but in computer science, we use the word string. And it just stores text, such as like words or sentences, paragraphs, or even just a single character, so like an A or a B. You know that data is a string because it's surrounded by quotes. So for example, right here, rock is surrounded by quotes. And so that means that rock is a string. Or for example, I could type in here, favorite word. I could say meat. And that would create a string with my favorite word. Of course, the other big type of variable is an integer, and they store whole numbers. So if you have not taken sort of like, I guess maybe an algebra class is maybe where you cover integers, that is only the whole numbers. So 1/2 is not an integer, but 1 or 2 or 3 are integers. You can't store any decimal part. So I could, instead of writing my favorite word, I could say favorite number. And I could say, 42. That's not my favorite number, but my favorite number is a secret, so I'm not going to tell you that. Let's say it was 42. That would create a variable with 42. Okay, that was kind of our quick deep dive, well, shallow dive into variables and types. That was a lot to take in, but as of now, we have gone over loops, functions, and variables, and that is actually like the fundamentals of programming. That's kind of all of it. Obviously, you get to more advanced stuff, but sort of your first 4 weeks of a computer science course, that's what you're covering. Now, if you've already taken a computer science course, hopefully that was review. But if you have not, congrats, you've passed your first exam in computer science. Now, the most important thing to remember here as we dive in is that the computer is looking at the rules to decide what to do. The computer is never doing something that we did not explicitly program it to do. So we're going to dive in and look at one of those rules. Let's go down to player make move, ask move right here. And we can scroll back up. If you could even just search for ask move, and you can see the definition up here. So this is how we define a function, and we can see its the rules that it's following. So, we're thinking about it. We're thinking about moving. Okay. Let me know if you've found this function, or if you can't find this function. It should be on line 12. And then we will dive into it. And that will give my computer some time to think. Because it needs it. Cool. So this first line here is asking our user to type in what move they want to use. Now, by using this input function, we are telling the actual computer to print out what's inside these parentheses, and then to wait until the user types something in the console, and then return it, and then hit return or enter. It'll then take whatever they typed and store it in this variable. And what they typed is going to be a string. Now, if the move they enter isn't valid, we want to print an error. And so that's where this little check happens. We say if move not in valid moves, which our valid moves are right up here, where we say rock, paper, and scissors, then we're going to reprint that is not a valid move. Otherwise, we're going to return the move. So remember how our game loop originally uses a conditional to keep the game running until a winner is declared? Our rule here is actually another conditional. It's checking to see if something is true. And in this case, it's checking to see if the move they gave us is not in our valid moves. So for example, if this input function ran, and I can actually show you this right here, if I ran the game and I said yeet, it's going to take that string yeet, I'm going to hit return. And so what happened is it stored yeet into move, and then it says that is not a valid move because move was not in our list of valid moves. And computer continues to think. Yes, Adam, someone did say yeet. It was me. Guilty as charged. So something we've kind of been talking about implicitly that we're going to actually call out is this idea of an if statement. Sometimes we only want to execute a block of code if something is true. And that's exactly what we've been doing here. It is only going to run this line of code if this statement is true. And if you think back, this is actually really similarly formatted to our while loop because it's indented in past our if conditional. We also have this this else statement that basically says if this thing did not run and we don't run this line, then run this line of code. And in this case, we are just returning the move that the player used. Now, remember how we talked about both our strings and our integers as kind of two big types of variables. Well, there's a third really big type of variable that we actually have been using without talking about it, and that is a Boolean. Have you ever heard about Booleans before? Drop in the chat if you have any crazy Boolean stories. There's a really, really good sticker from the Hackathon Queer Hacks that says, on my cyber Boolean shit, and it's like my favorite sticker ever. It's incredible. I think I'm allowed one curse per live stream, and that was my bad word for this one. It's a neat sticker. So Booleans are a type of variable that contains true or false. That's all it can contain. It can't be purple. It can't be 17. The only thing that a Boolean can be is either true or false. And you might say to yourself, like, well, how useful is that if it can only store one of two values? And the answer is it's actually incredibly useful. Because Booleans are only equal to true or false, that means it can represent any kind of conditional or the ultimate evaluation of any conditional. So, for example, our expression here, move not invalid moves, this ultimately is going to be turned into a conditional because it's comparing these two things. It's saying, is this thing inside this list? And the answer to that is either yes or no. It's either true or false. And so that means that as a whole, that is a Boolean. So we're going to recap. We kind of went over this, but we're going to take it one step at a time and look at what is our if statement actually doing. And our if statement is evaluating this expression, and it's checking, is this string move inside our list of valid moves? And if it is, then this evaluates to a Boolean true, and it's going to run this line of code that says that's not a valid move. If it is not, if it is not, it is true, and it runs that line of code. If it is in our list, then this expression evaluates to false, and it just lets us play that move by returning it. So we'll circle back around to this idea that all we're doing is just following these rules, and that's all our computer is doing. If statements run the code if a Boolean evaluates to true, and that is just kind of a simple rule. Now, building a game, or the game that we're building, it just involves putting these small rules together. So I'm going to hop back to our slides for a second. Boop. Oh. just so you can enjoy how slow slides is being for me too. Adam said he didn't hear the bad word, to which I say, good. That was the point. I said it very quickly and quietly. Okay, so we're going to build an AI-based opponent. We have welcomed you. We have introduced you to game programming. We have kind of walked through the building of rock, paper, and scissors. And now we're actually going to build our AI-based opponent. So we've walked through how we make our moves, right? The computer asks us for input. It checks to make sure that input is good. And then it kind of returns that back to our main game loop. But the computer makes moves too, right? If you remember inside that game loop, we have a line that says the computer move is equal to make move. So it's calling a different function. Now, before we actually look at that code and we see how our computer decides, I'm curious, how would you make your computer decide what move to make? And I actually would love some comments here. So, I mean, here's a dumb strategy. I would have my AI would always return rock. Or always pick rock. That's my AI right there. That's intelligent. And that's a rule, right? It's a very, very simple rule that just says whenever you're asked for a move, that move is rock. But that is a rule. Now, I think that the silly part here is that we really wouldn't talk about this as being AI, right? And I think there are a couple really fun big words out there. I mean, the two big ones are machine learning and artificial intelligence. And sometimes we treat those as being the same thing, but there really is a difference. Machine learning has a very specific technical definition, but AI is just anything that seems intelligent, right? Any computer that is able to make you think, wow, it's really smart. So, for example, if I always play scissors, then an AI that always plays rock, I might think, dang, how is this computer always beating me? It's so smart. That would, of course, require me to not be particularly good at the game rock, paper, scissors. Let's see. We have someone saying that they would do random moves. And this actually, as I understand it, is not a particularly bad strategy. I mean, one way we can think about it is that how much can the player take advantage of the AI? And if the AI is just always picking randomly, fundamentally, there's nothing really that the user can do to take advantage of the AI, because it really never knows what the AI is going to do. So I think this is actually like not an awful strategy. Again, whether or not it's considered artificial intelligence really boils down to how the person is interacting with it thinks about it, right? So we got some ideas out there. We got always return rock, and we got random moves, both of which I think are, based on the context, could be good. But the way that we do it is right here in this statement, make move, which we can actually I never know when to kick off the slides and when to actually look at the code. So I will be bouncing between them. But if we scroll down here to make move, we will see this is how we're actually following the rules to make it. So we can see we have our actual move that we're returning is coming from valid moves. So we always know it's going to be either rock, paper, scissors. But we're using this number to pick it. So where is that number coming from? If this number is 1, then we would pick paper. If it's 2, we'd pick scissors. If it's 0, we would pick rock. And the answer is that we're actually getting that number from the length of our state. So remember earlier, we store each one of our moves in our state list. And when there's no moves, that list is 0 long, right? If you ask for the length of that, this function will return 0. One thing that we'll take a look at is this modulo operator, which basically just means take the remainder of a division. So if you remember back to when you had to do long division in, for me, it was, maybe like 4th grade, you divide the thing and there's some bit left over, right? So if you divided 3 with this, the remainder of 3 divided by 3 is just 0, right? It divides perfectly in once. But then if you divide, 4 into 3, well, you get 3 out, and there's 1 left. So that modulo just says, give us what's left. And what's nice about it is that if you're taking this modulo of 3, you are always getting a number that's going to be less than 3. You can either get 0, 1, or 2, which is nice because the indexes of our list are 0, 1, and 2. So we know we'll always have a valid index for our list to pick from. Now, as our state grows, that means that we're going to continue growing that number that is our length, but our modulo will always take it down to be either 0, 1, or 2. Now you can see we'll also have a catchphrase here, and we print that catchphrase out, but then we just take that number that's fundamentally just how long is our state list, and that's how we pick which move we're going to use. So we've talked a lot about how both the AI is playing and how we're playing. So let's cut with the chit chat and actually play a game. I will quit out by touching Control-C. I'll clear, and now we'll play it again. Here, let's make it big. So this is actually, now that we know how the AI is behaving, we actually do have kind of a chance to sort of cheat the AI, right? So I know right now that the state list should be empty, which means the length of it is 0. And 0 mod 3 is still 0. So that means it's going to take the 0th item in valid moves. And if we roll up, we can see that's rock. So if I want to beat rock, then I would type paper. And if my understanding of this is correct, then paper should beat rock, and that should be what they play. Oh, that's interesting. Apparently I did misread because I typed paper, and it says we had a tie. That's unfortunate. Oh, pardon me. For anybody that doesn't have their terminal, remember you can come down to Tools, click on Tools, and then just click Terminal here. And all you have to type is python3 game.py. Bazinga. So that is the command that you can run to play yourself. So I'll just keep doing paper. Oh no, I lost. Let's do paper again. Okay, I won. Now, if it is rotating through in the same way, that means that it played rock on this turn, and it'll probably play paper on the next one. So I should be able to play scissors. And I won again. And so now I should be able to play rock and win again. Incredible. I won, and the winner of the 5 games was me. John, I'm really sorry that the slides is it's kind of syrupy today. I'll get a new computer soon, I promise. So, did you see, we mentioned it earlier, but our computer always shouted the same catchphrase when it was making a move, and it shouted bazinga. And I don't think that's a very good, I think that's a very good catchphrase. So we're going to fix that. This is going to be our kind of first edit that we're going to make, is we're going to give the AI a better catchphrase when it makes its move. Now, this is a question I'll put to everyone, is that if we wanted to change our catchphrase, how would we change that in the code? What line do you think we would have to change? And if you think you have the line, throw it in the comments and make your guess. And if you know which line you need to change, then actually tell me why you know that's the line to change. So for example, if you thought it was this line you needed to change, you would type 32 and say it's 32 because, some reason. Okay, someone guessed 47. Can you give me your explanation for why you picked 47? It shouldn't be too hard of an explanation. Grape pizza. Wait, does this mean that you eat pizza with grapes on it? Is that a thing you do? Yeah, someone's username is Grape Pizza, and I'm like both repulsed, but also kind of interested that someone might do that. I mean, to be clear, I like pineapple on pizza, and so I'm not here to, to shame other people's pizza preferences. Adam said, maybe you like WAP, wine and pizza, because that is what WAP stands for, as I'm told. I wouldn't know, but that's what I hear. Okay, yeah, so it is line 47 that we need to change. There are many ways you might have been tipped off. Maybe it was the fact that we have Bazinga there. So if you're trying to change something that says Bazinga, maybe just look for the phrase Bazinga. Maybe it's the comment that says you'll have to update this to have multiple phrases. So we're going to fix this. We could start and we could just change the actual word. So for example, we can come in here and just type yeet. And we could run our game again. And we could say paper. And then we could say rock. And we can see each time we have the catchphrase yeet here. And because it has these quotes around it, we know that that's a string. We can pull on some previous knowledge. Yeah, okay, Great Pizza said the line stores Bazinga, which is exactly one way that you would find what you need to change the thing that's printing out Bazinga. Also, one other tip, if you are playing through and you want to play more, you can actually just press the up arrow key, and you can get that command again. Good night, Adam. Sweet dreams. Okay, at this point, is anybody getting any errors? You should have been able to update your catchphrase, and you should, when you play the game now, see your new catchphrase. If anybody's having issues, this is a time that I would love to help debug with you. No bugs. I'm seeing one person say that they're doing fine, which is great. If anybody is having issues, let me know in the comments, and we can chat about it. So this is great, but what if we wanted to have multiple different catchphrases? So what if we wanted to say wanted to have 2 or 3 catchphrases? Well, currently our catchphrase is stored in a variable, but variables only store a single value, and we want to store multiple values. So can you think of what would be a better fit here than using a sort of single variable? It's something that we've seen in the code at least once before. Kind of slipped it in there. We didn't make a big deal out of it. If anybody knows, drop it in the comments. I'll be very proud of you. Yes, Great Pizza coming through. Well done. It's a list. We're looking for a list that can store multiple values. Lists are really, really helpful, and they're usually a data structure that you're going to want to reach for whenever you want something to contain multiple values. So we're going to change our code to store catchphrases not as a single variable, but as a list. So what we're going to do is use square brackets. Right here, we'll do an opening square bracket. We'll have yeet. And then we'll do a comma, and we'll add something else. So maybe we want to add back in Bazinga. And maybe we want to add in Booyah. And then at the end, we'll add a closing square bracket. So everybody let me know if you have any problems creating your list. And now, because our list contains multiple values, we need to be able to pick one. So we could just, instead of instead of picking one, we can just print out the entire catchphrase list. And we can see what this would look like if we play our game. We can say, okay, rock. And then it says, it actually prints out all of them at once in that list, which is fine, but we really want to pick one catchphrase at a time and print just that catchphrase. So we want to use what's called an index, and that is the number of the thing we want to pick. So here we could say 0, and that would give us the 0th item in the list because we start counting from 0. So this would give us yeet. So if we quit out of here with Control-C, and we up arrow to get Python game again, and we hit run, we could say rock again, and look, it just said yeet. So this is great. We're able to pick something out of our list, but we don't want it to always pick the same thing. And so this is something that we want we want our computer to do. But here's the problem: is that computers are on some level very dumb. Like, yes, seriously. They do exactly what you tell them to do, but they're not going to understand anything if you make a typo. They're just going to play dumb, and they're going to say, I don't know what this is supposed to be. And there are lots of little typos that people will get caught up on. In some languages, you use semicolons at the end of every line. Luckily, Python is not one of those languages, but it's one of the most common errors that you'll say, we're just missing a semicolon. In Python, some of the common things are not indenting correctly, or missing a quotation mark if you start a quotation. Now, a lot of programming is making things match up. So quotations, if you have one opening quote mark, in order to complete the string, you need a closing quote mark. And this is similar when you declare a list, because we have this opening square bracket, we need a closing square bracket. It's very possible that if you had an error, that it might have been missing that closing square bracket. The other big thing, of course, that we just mentioned is indentation, that if you indent this, then everything that's going to be part of this function also needs to be indented. But one way that we could make our catchphrases rotate through to get new catchphrases for each turn is to use that same number we were using. Remember, number just kind of gives us a number from 0 to 3, or sorry, from 0 to 2, 0, 1, or 2, based on how many turns we've already taken. And so we can actually make use of that number. Instead of saying the 0th item, we can say the number item. So if we quit out and we run again, we should actually see this in action. So if we make our move rock, it says bazinga. But then if we make our move scissors, we get booyah. And then if we play again, let's say paper, it says yeet. So it cycled through all of our individual items. Now, right now, our game is mostly working. But as we saw, our AI, if it can be called that, is just cycling through a list, right? As we talked about earlier, it's going to start at paper and just cycle through, which means if we want to start again, okay, I know it's going to play paper, so I'll type scissors, and I win. I know now it's going to type scissors, so I can type rock. I win. I know it's now going to type rock, so I'll type paper. I win. I know it's now going to type paper again, so I type scissors. I win again. I know it's now going to type scissors, so I'm going to type rock, and I win, and so I won all of them. And this is because our AI is fundamentally predictable. This is what we were talking about earlier, where someone suggested randomness, because once I know what the AI strategy is now, I can perfectly exploit it, and I can always win. And this is kind of beyond just being, a bad AI. It's kind of boring. So we're going to get in and we're going to fix that. And I'll jump back to some slides. So how are we going to make our AI smarter? Oh, it's thinking about resizing. Come on, you can do it. There we go. So one way we could think about doing this is to, instead of looping through all of the moves, we could make it beat the opponent's last move. That way, if they try to be sneaky and kind of keep playing the same move, the computer will always win. And this is actually, I think, a little bit better than what we're currently doing. So we want to do this by actually going in and editing the rules that our computer uses in make move. So find make move in your code, and it is down here, the one that we were just editing. And I could have found that by just typing make move and hitting return here. There we go, make move. So now we're going to get in and get our hands dirty. First of all, we are going to actually comment out where we currently establish our move. So this is no longer going to happen. And this is just by adding a hash mark or a hashtag or an octave or whatever you call it. Now what we're going to do is we're going to say our last move, and we're going to set it equal to our state, which is a list, and we'll use the number -1. Now in Python, -1 is a special index, and it just means whatever is at the end of the list, right? So if you had a list here, this would be number 0 is yeet, number 1 is bazinga, and number 2 is booyah. But another way of referring to the last element is just -1. So in this list, -1 would be booyah. So this just gives us the last move that the player made. Now we're going to use some conditionals. And we'll say, if the last move was equal, and we use the double equal sign to compare here, and then we'll use the string rock, then we have to add a colon to give ourselves this if statement and hit return. And you can see that we're indented here, so we have a little indented block. And so here we can just set move equal to what would be rock, and that is paper. Now we're going to use, we looked at if and else, but now we're going to use a kind of special statement you can put in between, which is called the else if or elif. And you just type ELIF, and that is else if our last move was equal to paper. Then we would want to return whatever beats paper, which in this case, we would say our move is scissors. And then finally, we can just say else, and we can say, at this point, if it's not rock and not paper, then we know their last move has to have been scissors, and so we can just say our move is equal to rock. And then at the very end, once we've picked that move, we just return it. So now our computer has some big brain energy, and let's see if it works. Again, if you have any issues or you're getting any errors, drop those issues or errors into the comments and we can take a look at them. Otherwise, just get into your terminal and type Python 3 game.py and hit return. Okay, let's pick scissors because I won with scissors on the first term last time. And oh no, I lost. Okay, well now, what if I type scissors again? Oh no, I lost again. What if I type scissors a third time? Oh no, I lost again. And this is because the computer is able to see that I type scissors and it is now it's now able to beat me. So what if I tried something different? I know if the rule is it knows that I did scissors last time, so it's going to try to beat scissors. That means it has to be playing rock. And so what if I played paper? Congratulations, we won! And this is because it didn't know that I was going to play paper. But if I play paper again, because it's the same as my last move, it should beat us. And I lost that last round. So it seems like this is working well for us. Is anybody having issues with completing this function? Are we doing well? All right, I'm going to take the lack of comments as a sign that everybody's doing great. So our computer is like a little bit more tactical now, but it is also super predictable, right? If it's always beating my last move, then I could always change my move and still always beat it, right? I could exploit it. And we don't want the player to be able to do that. We don't want the player to be able to just guess what our move is. So what if we only made the computer do this sometimes? that this sounds kind of complicated. We want to write some code that half the time will choose a random move, and then use the move that would have beaten the opponent's move the other half of the time. Writing our own code to do this would be difficult, but luckily Python has what we call a built-in function that helps us out here. And built-ins are just functions that you kind of always have access to in Python. Now, we're going to use a function from the random library that we bring in for this import statement on line 3. And we will jump back down to our make move. And right here, we will type a new if statement. We'll say if random.randint 0, 1 equals 0, and throw a column. So let's talk about what's going on here. We are using the random library, and from the random library, we're using the randint function. And we're passing that function two things. We're saying the lowest number it can be and the highest number it can be. And so if the lowest number is 0 and the highest number is 1, then that means we're going to get either a 0 or 1. And that means 50% of the time it should be a 0. And this means that this will be true about 50% of the time randomly. Now, because we have a colon here, we know that after that colon, we need things to be indented. And so we can take this whole, select all of this if statement, and press tab to indent it. So now all of this code runs only randomly half the time. Now we can add in an else clause. We can say else colon, and that will indent. And so this is where we want to say, make a random move. Now, we're going to take a moment here, and I'm going to suddenly become less knowledgeable about Python than I am. And this is actually not untrue, because nobody actually remembers all of the functions all of the time, right? When I am doing my job as a software engineer at Google, most of my day is spent Googling to find functions that at some point I knew about, but that I have since forgotten specifically how to use it. And luckily, that's totally okay, right? So what I'm going to put everyone up to now is to have a go at Googling how to choose a random item from a list in Python. Here, I'll even pull it up. Google.com. Boom. This is what it looks like. It's a search engine. It's nice. I would recommend it. Or I'd also recommend DuckDuckGo if you want to use that. People like that. I would not recommend Bing. I'd recommend, DuckDuckGo is good. Oh, there's one called, I think it's pronounced Ecosia, that plants trees. That one's fun too. Ecosia. The search engine that plants trees. There you go. So that could be fun if you like trees. I like trees. But you can also use Google. Google's good too. Okay, so I've given everyone a second. Oh, wait, actually, this is the perfect time to slip in some Kalimba music. Keep Googling. If you haven't found it, Google how to pick an item randomly from a list in Python. And I will give you some background music for a second. All right, can anybody name that tune? It's literally like the one song I know on Kalimba. Actually, that and Smash Mouth. I know Smash Mouth on the Kalimba, but I wasn't about to play that. Oh yeah, I already guessed it. The Avatar music. Yeah, it is the love theme from Avatar: The Last Airbender. Okay, so someone said use random.choice. And this is, I think, a fair guess, but this is me pretending that I don't know how to do this. So I will jump in and I will Google. And I will say how to pick an item from a list, Python, random. Oh, look at that. It even pops up for me. That seems like a good query. Okay, how can I randomly select an item from a list? Let's just click on the first result and see what we get. And look at that. The first answer says use random.choice, which is exactly what Great Pizza suggested. Well done. Well done. And that is what we will do. But before we do that, before we jump off, let's actually look at how they're recommending we use it. Okay, we have a list here, just like our list of actions, and we have random.choice. Okay, that's kind of like how we used random.randint. And then we just pass it our list, and it prints that out. Perfect. So let's hop back to our code and fill that in here. So we will say random.choice. We already have the random function, or the random library from our import statement above. And we will just pass in valid moves. And we will say move equals random.choice valid moves. Incredible. So now let's hop back in and test our code and see if it works. We'll do Python 3 game.py. Let's make our terminal bigger. We move this up. Okay, so I'm going to guess scissors. Or I'm going to play scissors. We both played scissors to tie. Okay. Well, I know half the time it's going to beat my last move. So if it's trying to beat scissors, then that means that it would do rock. So that means that I'll try playing paper. Oh, is it tie again? I guess it randomly chose paper. Okay. Well, now I know if I played paper last turn, it has a 50% chance of trying to beat paper, which means it would play scissors. And so maybe I'll play rock. Oh my goodness, it was a tie again. And so very quickly, you can kind of see this is not particularly easy to game or to beat, because I have to think about all of this randomness. And we're going to hop back to slides for a second to talk about this randomness. Wow. I feel a little bit, what's the word, validated when I put the slides up, because it's like you can see Google Slides is really trying its best, but it's not good enough. Okay, so this is so random, right? Our computer is now a lot more difficult for us to actually beat. Half the time we know it's going to be random, and half the time it's going to be based on our previous move. Wait, this sounds kind of familiar if you've taken a particular kind of math class. Let's hop into some math. So this says 8th grade math. I'm not sure when you handled conditional probability. But knowing that this event is going to happen 50% of the time is called a conditional probability. This is what I was talking about when I said, oh, well, 50% of the time it's going to try to beat my last move. Another example of conditional probability is a coin flip. 50% of the time it's going to land on heads, and 50% of the time it'll land on tails. So conditional probability is the likelihood of an event occurring really given something. If you know the setup, it's the probability of that happening based on your setup. So our opponent is pretty smart, but I think we could actually even make it smarter. Biggest brain, biggest game time. We're going to try to make our computer even more tactical. So we're going to write some code that keeps track of the player's previous moves, and 50% of the time it will use the move that beat the one, not that they most recently used, but the one that they use most often. So if I tend to use scissors a lot, then half the time we will play rock. If I play paper a lot, then it will play scissors. Bazinga. Let's get coding. All right, I'm going to ditch the slides again, and you will not have to see how slow slides is being for me. But you saw. I probably have some sketchy extensions installed. That's probably it. I probably need to clean up my Chrome extensions, to be perfectly honest. All right. So we are going to hop into our make move function here, the same one that we've been editing. And in this same little slot here, where we said if their last move is rock, paper, if their last move is paper, scissors, and otherwise their last move is rock, we're actually going to delete all this and hit return again to indent it. And we're going to say if, you can code along with me here, we're going to say if most common and pass in our state is equal to rock, we're going to say move equals paper. Then we're going to say elif most common, and we'll pass in the state, is equal to paper. We're going to say move is equal to scissors. And then else, we will say our move is equal to rock. Because at that point, we know that their most common move was scissors. Now, you might be wondering, well, most common, where is this coming from? And if you scroll up, we have this function already implemented for us. You're welcome. And this does some slightly more complex logic, but it goes through and it counts how many people, or how many times our opponent was playing different things. And then we just compare things and we return the name of the thing they use the most often. So for example, if the count of times they've used rock is greater than scissors and paper, then we return rock because that's the most common. Otherwise, if paper was more frequent than rock and scissors, we return paper. And if not, then we know that scissors must have been the most common, and so we return scissors. Now, one thing that you may notice is that we're using a list here, or we're using a for loop here, which is a kind of loop that we actually have not talked about before. And this is on line 27, and this is 27 for me right now. And this just means to go through everything in a particular list. So remember, we have our list of, which is our state, which is the list of all the moves that the previous player has made, right? And so we're saying, go through every one of those moves and then run all this code. This is like a really convenient way to process everything in a list. So for loops iterate over a sequence, running a piece of code a certain number of times for the stuff in that list. Now, this is a kind of a big chunky conditional that we just talked about. And we're using these conditionals just to compare the count of each of our moves, right? And it's a little bit complex, but you can work through it. And kind of what I was saying earlier, that this ends up returning the one that is the most common, or the count that has the highest number. And you can actually convince yourself that this is true, right? If our rock count is greater than or equal to our scissors count, and our rock count is greater than or equal to our paper count, then that means that rock is our most common move. One thing to note here is that we're not using just a greater than sign. We're using a greater than or equal to sign. This means that we're always going to get a value here. But this also means that we kind of don't care what happens if they have two different things that are the most common, right? So in this case, if rock has the same amount of count, like imagine they played everything exactly once. Well, then we say, okay, rock count is 1, and it's greater than or equal to scissors. That's true. It's equal to scissors. And then rock count is 1, and paper count is 1. So 1 is greater than or equal to 1. So that's true as well. So in that case, if they've played everything exactly once, then we'll just say that rock is their most common, and that's just what we'll go for. So we've made this little update, and we're going to go test our code again. Let's quit out of this, and we'll run python3.gain. And you can play along, right? Run your code as well. And so, okay, I'll start with rock. Oh, it was a tie. Okay, I'll try rock again. Ah, it was a tie again. I'll try rock again. At this point, at some point, it should start benefiting from the fact that I play rock a lot. Oh no, I lost. Okay, let's try rock again. But because sometimes it's random, I might still have a chance of winning. Ah, I lost again. Okay, one more time. Okay, it was a draw. And because we drew enough times, I guess that means that, the whole game was a draw. Even though that doesn't feel right because we drew 3 times and they beat me twice. But I think that's fine. We had a draw. Now, is anybody at this point having issues getting this to work? Because if you are, I will help you debug. But if you're not, good for you. You're killing it. All right. I will take the lack of comments as an emphatic, heck yeah, Will. No bugs, which we love to see. Oh, I see some fun emojis. So let's hop back into the slides, if they will cooperate for us. Oh, it's loading. Isn't that great? I mean, like, it is good that it is loading. It's not, it's not just sticking up its middle fingers at me. It's trying. It's trying its best. Oh, it said I'm not going to present well. I said I'm on break. Maybe if I try presenting again. Maybe not. Maybe not. Oh, this is looking good. Okay. We're loading. I have like 4 slides left, so this is particularly funny. It says we did it. Yeah, that's the slide that we're gonna go for if it full screens for me. If not, that's fine. Okay, we're full screen. We did it. Yes, congrats. So the computer is calculating the conditional probability of you making a move and is using this to decide what it should do to beat you. And you just coded a really basic AI. A fun little detour we'll take. Yes, yay! Thank you, Sean. This is actually really cool. Another thing that you did is, remember earlier I said we have these 2 terms, artificial intelligence and machine learning. And artificial intelligence, some people have definitions for it, but mostly it just means, is your computer doing something that makes it seem intelligent? But machine learning has a very specific definition. And the actual definition of machine learning is it's when a computer gets better at a task, when the computer gets access to more experience. And this can mean a lot of different things, but this is the definition. And one way you can read this is that if the AI plays against you more, then it should get better at playing against you. And we can actually see that in this case, what we've coded up is machine learning, because the computer is learning from all of our moves what move we're most likely to do, right? If I play rock a lot, then over time, as it gets more experience playing against me, it learns that I play rock a lot, and it will start playing paper more, or whatever the right thing is. So you coded not only a basic AI, but also an AI that uses machine learning in some technical sense. So we've done a lot together, but now it is time for you to go out and adventure into the world with your newfound AI for game development. It is your turn to mess up this code and make it do different things. Like I said, this is, I think, the best way to actually learn how to program. So we wrote a lot of code together, but you can really get in there and mess things up in a good way. Here are a few ideas of things that you could alter, some kind of fun challenges. One is you can adjust how frequently the computer plays a random move. Maybe only 1/3 of the time it plays a random move, and 2/3 of the time it tries to use its machine learning. You could actually make the computer sometimes do the opponent's last move, and sometimes their most frequent move. You also could be super evil and usually play the same move just in order to try to get inside their head and trick them. But these are just some ideas of places you can take this. So we have done our AI-based opponent, and now we're moving into our kind of review and recap. So you have just built your first, perhaps not your first, but you have built an AI, or artificial intelligence. You have learned the basics of how to make a game, from storing state to the event loop. and you have learned that Python is a general purpose programming language that you can use for all sorts of fun things like machine learning or even game development. You've learned how to search for new answers online, which honestly might be the most important part of this whole workshop that you could take away. So, without further ado, I'm going to drop a little quiz in the comments that I would love for you to take. It's not serious, it's just a few questions, but it's a nice way to solidify what you've learned today. And so I'm going to, well, I guess I'll just type that out. It's mlhlocal.host/quiz. Boom. It should ask you where you're taking or where you did this event. And there might actually be a local hack day learn option. If so, pick that. Otherwise, you can just say no organization because we're doing this with MLH. But that should not be a problem. And while you were taking that quiz, I will I'll grab my ukulele. I'll play some ukulele for you. Don't look at how dirty the closet is. I just moved. Okay. If you haven't taken the quiz, click on the quiz. It's right there. It's easy. And I'll play you like 4 notes on the ukulele. I don't know, people like it when I play instruments. I'm not particularly good, but I think it's just kind of fun to see someone who's supposed to be teaching you to code play ukulele. I'm probably very out of tune. Great Pizza asks, how many instruments do I play? The 3 big ones are the kalimba, the ukulele, and the piano. But I don't have a piano, and kalimba and ukulele are really easy to carry around. Oh, actually, I have a song about birds and where they come from, and I'm going to sing that song for you. I am so unsure about so many different things that I have heard, but there's one thing of which I am certain, that the government invented birds. They are fake, you can see it in their eyes. They're the NSA's favorite little spies. But there's one thing of which I am certain, that the US government invented birds. Stay woke. All right, hopefully now you've taken the quiz. It actually dawned on me that I probably shouldn't have sung because singing distracts people. I should have just strummed and had some good background music. But you got what you got, and hopefully you've had a second to take the quiz now. So we'll just hop into some next steps, and maybe we'll leave some time for a little Q&A in case anybody has any burning questions. The computer has some awesome catchphrases, but the player, I think, deserves one too. So you could try adding a spot for the player to put in a catchphrase. You also can try to make your AI better. Big spoiler alert, scientists actually have found the best rock, paper, scissors strategy. And so you could actually research this. You could literally go look up a paper, an academic paper, that kind of proves this is the best strategy for rock, paper, scissors. And then you also can actually add extra moves. This is like a big thing that people have their own versions of, right? You could add shark and potato. So it could be rock, paper, scissors, shark, potato. And you could decide which moves beat other moves and kind of make it your own. But that is our workshop today, friends. Thank you again so much for coming. I had a blast. I always love an opportunity to talk about Python and machine learning and AI and to play games. So I will hang out for a second in case anybody has any questions. These could be questions about the workshop, about machine learning more generally, questions about Major League Hacking or Google. I'm game for anything. But if you have no questions, then we can just I guess not call it a night because I don't know what time it is where you live. But we could call it a workshop and leave it there. But I will hang out for a second to see if anybody has any questions. We got the instrument question. The answer is kind of 3. Only 1 well. I play piano better than I play ukulele or kalimba, but I don't have one. Actually, in high school, I did like piano competitions and stuff. I go play classical songs for professors. It was fun, I guess. It was fun. No other questions? It's looking like no other questions, in which case we can call it a workshop. I will say thank you again so much for hanging out with me. Oh, we got a question. We said Sleepyhead is awake. Hi, I just came. Am I too late? For this workshop, in some ways, I would say yes. We're basically winding down. We're just doing a Q&A of any burning questions. But we had a good time, and you can definitely sign up for this workshop in the future. If you go to I think it's MLH.io /events. You should no, not /events. Let me actually grab you the link. I think it's localhost MLH events localhost. This is me just Googling this to find the right link for you. Okay, you should be able to attend a workshop just like this one if you'd like later. We have a question from Great Pizza. What's my favorite thing about working at Google? This is a good question. I like working at Google. It's a good job. So I actually work on. I know the answer. So I work on a team that does what we call competitive cloud benchmarking, and this is like code for just writing different programs to test to see how good is GCP, how good is AWS, and how good is Microsoft, and specifically like what things are they good at, right? So for example, you might have one cloud that has really good cheap storage, but another cloud might actually be faster at doing certain compute tasks, right? These are different kinds of trade-offs. And the thing that I actually really love is, so the specific project I work on is to test availability, which basically just means we put a server in every cloud, in every region, in every zone in the world, and we just have them constantly talking to one another. And what's really cool about this is that when something happens, like a data center goes down, or like Microsoft had this issue a while ago where they had this data center issue in India where it got too hot there. Like it was literally just too hot and the computer stopped working. And there was an article about this published, I think in the New York Times, and I actually saw that in the data. And so something that was really cool. One thing that I really like is just kind of the scale that we get to work at, and to be able to like actually look at the whole internet at like one moment in time and say, yeah, this is what's going on. So some other good things are, I love the people there. There's a lot of free food and like free yoga classes and stuff, and all those things are nice. But I think getting to see really big things can be really fun. Let's see. Sean said, I did not find the event name in the quiz link. Which event should we select for the quiz? Let's see. I will actually just hop on that quiz. Let's see. mlhlocal.host /quiz. Not quick. mlhlocal.host /quiz. Which event? Oh yeah, that's actually a great bugs notify us. Let's say just click part 3. Part 4 is relatively new, but I'll give someone a note to update that. And yeah, you for school or organization, you can just say MLH, and you continue through there. Yeah, the free food is good. The free food is very tasty. And they also actually have really nice, they have cafes that you can go to for free. They'll like make you coffee or make you pastries. But they also have really nice espresso machines that you can use. And I love playing around with the giant espresso machines in the Google office. It's nice. Alrighty. If we've gotten all our all our questions answered, then if anybody has other questions, kind of drop them in now, speak now, or forever hold your peace. But if not, I will say again, thank you so much for hanging out with me. It was a blast. I really enjoyed it. And I look forward to seeing you at kind of future events. Tomorrow, I am doing actually a coffee-themed event, and then I'm also doing another AI event tomorrow. So look for that in the schedule. I'd love to see you again and hang out with you. You are so welcome. Happy Saturday or Friday or Sunday, whatever day it is for you. And happy hacking, friends. I'll see you around.